Oh, this is a nerve-wracking presentation. So what then drives the marine ecosystem in the eastern Great Australian Bight? What is it? Well, we reconstructed chlorophyll A profiles. Profiles, what I mean is vertical profiles from the surface to the bottom. And that gave us the first clue. Look at that. Look at that. Here are some examples. Here on the left are temperature distributions, temperature profiles. On the right, chlorophyll A. The chlorophyll A, the green lines from the surface to 100 meters, and at the surface, very low value. This is in the eastern Great Australian Bight, not in the upwelling center. So we're talking about the region where the Kangaroo Island pool is. Okay, have a look at it. What do you see? You see, what do you see? You see big values at a depth of 40, 50, 60, and even 70 meters. Look at it. Look at it. Here we are. You know, it's more than 1 milligrams per cubic meter. This is what you get at the surface, but only not every year. You know, this is what you get here below the surface. So the answer are subsurface phytoplankton. So how are these created? They are created through a number of measurements. So you have nutrient limitation in surface water. So not enough nutrients reaching the top parts of the euphotic zone. This is what we call nutrient limitation. And on deeper layers, you have a light limitation. But between, you have enough nutrients and lights just below the base of the surface mixed layer to support photosynthesis. This is what creates these subsurface blooms, but they are significant. Well, okay, you still don't believe me, but that might be just a freak measurement or so. All right, where are they? And we got reconstructed. For some years, we have a very good coverage of these calibrated chlorophyll A profiles. And I show you a map, again created using GIS. Here's a map. All right, so what does this map show? There are lines which tell you the depth, the average depth. Where is the maximum? Okay, it's not the depth of the ocean, it's the depth measured from the surface. At what depth is the maximum of chlorophyll A? Okay, have a look at it. You see 55 meters, 45, 60. Okay, and there are some contours here, 60, and then it gets deeper. How? Okay, so there are depths 50 to 60 meters. What is the value? How big are these subsurface blooms? And you can see in the color range, if it's above, say 1.2 starts to be yellow, 1.4 and red is something like 1.6 milligrams per cubic meter. And you can see this. They're located in shallower water near the mouth of Spencer Gulf. Okay. And we also know that they move along the coast. That's why I have, let's see whether my simulation works. I show you the typical currents associated with this storm. So what the wind forcing creates, it creates something that we call an upwelling jet, and actually moves stuff around the coastline, along the coast. Okay? So there's subsurface blooms. Okay, we go back. Spend a little bit more time on the next slide. So that's fascinating, isn't it? This is for February 2012. Okay. So do they exist every year? Okay, let's talk about that. The final aspect.